this video, we will learn how to calculate the elasticity of substitution of a constant elasticity substitution production function. We are being given this CES production function is y is equal to x1 raised power theta plus x2 raised power theta whole raised power 1 upon theta. We need to find out the elasticity of substitution. By elasticity of substitution, what we mean? Elasticity of substitution measures how the input ratio changes relative to the change in the marginal rate of technical substitution. So in simple terms, if we have in place of x1 is L or K, and in x2 we have K in place of x1 and x2, then the elasticity of substitution would have measured the capital labor ratio relative to the change in the marginal rate of technical substitution between capital and labor. Okay, since we have x1 and x2 here, so we will confine our discussion with x1 and x2 here. So given this production function, y denotes the output, which is a function of two inputs x1 and x2. Theta denotes the substitution parameter, which is used to determine the elasticity of substitution. So elasticity of substitution, to calculate the elasticity of substitution, first we find out the marginal rate of technical substitution. Marginal rate of technical substitution, as we know, is the ratio of the marginal product of the inputs. That is marginal product of input 1 upon marginal product of input 2. So marginal product of input 1 is simply the partial derivative of the given production function with respect to input x1. So if we partially differentiate this function with respect to x1, first this 1 upon theta will become coefficient applying the power function rule, and exponent will be subtracted by 1, that is 1 upon theta minus 1. Then we apply chain rule and multiply it with the partial derivative of x1. Okay, so differentiating partially with respect to x1, whatever is in the brackets, that is x1 raised power theta plus x2 raised power theta. Clear? Now the derivative of x1 raised power theta, again using the power function rule, theta becomes coefficient and exponent is subtracted by 1. We get x1 raised power theta minus 1. Here theta and theta gets cancelled. We are left with this very stuff. When we subtract 1 from 1 upon theta, we will get 1 minus theta upon theta times it becomes x1 raised power theta minus 1 here. This is the marginal product of x1. Similarly, marginal product of x2 means the partial derivative of the given production function with respect to x2 this time. Okay, again the exponent becomes coefficient and exponent is subtracted by 1. Then we apply the chain rule and partially differentiate with respect to x2. Derivative of x2 raised power theta will be equal to theta becomes coefficient x2 raised power and exponent is subtracted by 1, that is theta minus 1. This is the marginal product of x2. Now MRTS, as we know, is equal to MP1 upon MP2. So MP1 is this term, MP2 is this term, so we divide these two terms. Okay, here since this term and this term are these two terms are same, we cancel them. So we are left with x1 raised power theta minus 1 divided by x2 raised power theta minus 1. So we are left with x1 raised power theta minus 1 divided by this very stuff. Okay, so MRTS will be equal to this very stuff. If I reciprocate numerator with denominator, I will get 1 minus theta. Now the elasticity of substitution, as we know, it measures how the input ratio changes, that is the change in the input ratio, that is x2 upon x1, relative to the change in the MRTS into MRTS upon the input ratio. The way we calculate the elasticity of demand, that is the change in the quantity demanded due to the change in price into price upon quantity. Similarly, in place of Q, we have this input ratio x2 upon x1. Okay, so using this very stuff here, since we know that MRTS is equal to this very stuff, if I transpose this exponent to MRTS, it will become 1 divided by 1 minus theta. Simple thing, if we have x raised power n is equal to y, it will become x will become y raised power 1 upon n. So exponent, when transposing to RHS, it gets reciprocated. Okay, so x2 upon x1 is equal to MRTS raised power 1 divided by 1 minus theta. It gets reciprocated here. So then we need to find out this very derivative, the change in the input input ratios relative to the MRTS. Okay, that means the derivative of this function with respect to MRTS. The derivative of this function with respect to MRTS will be, again, this exponent will become coefficient and exponent will be subtracted by 1. Okay, so elasticity of substitution will become then 1 divided by 1 minus theta, this very stuff, MRTS. When we solve this exponent, it will become theta divided by 1 minus theta into MRTS divided by x2 upon x1. x2 upon x1, as we know, it is equal to MRTS raised power 1 divided by 1 minus theta. Okay, bases are same. We can add up the exponents here. When we add these two things, we get 1 divided by 1 minus theta of MRTS divided by MRTS raised power 1 divided by 1 minus theta. These two terms gets cancelled. We are left with 1 divided by 1 minus theta as the elasticity of substitution. I hope you like this video. Thank you.